Hello, everyone. Chapter 3, Learning Target 5. This is Miss Osier.
And Miss Lahar.
And here we go. So, introduction of things with functions. It's a rule that assigns exactly one input value for each output value. The inputs are the x's, the outputs are the y's.
Okay, so to prove something is a function, you can draw yourself a vertical line and see how many times it intersects. So if you look at diagram A, it intersects that red line in 2 spots. In relationship B, it only hits it in 1 spot. So, which one? Draw the line in column B, explain which of the functions is a function and which is not.
It's this one. It's this one.
Yes, I don't know what I said when I...
Now, the reason it is because, remember, for every input, there can only be one output. If you fail the vertical line test, you're going to get 2 different outputs for the one input. So for this x value, you could get -4 or 4, whereas on the right, you can only get -2 or
positive 1.
1.
Way to go, Miss Lahar. Way to go.
That's all right.
Okay.
So it only has one y value for the input of 3.
Okay.
Oh, because you did 3, -2.
Oh, yeah.
There
Oopsie.
it is. That's fine.
Oops.
3, -2. The line we did a different
Okay.
line.
So the graphs, in order to be a function, have to pass the good old vertical line test.
That's the easiest way to figure it out.
If it hits it in 2 spots, it's not a function.
Okay.
Now, there's another clarification that you will learn in Algebra 2. It's called whether a function is a one-to-one function.
So what that means is that its inverse is also a function.
Okay? So basically, it has to have 1x for 1y and 1y with 1x. So to be a one-on-one function, you not only have to pass the vertical line test.
Because you got to be a function to begin with.
Yep, but you also have to pass the horizontal line test. That's what proves if it's a one-to-one or not. So, is it a function?
It's a function.
Is it? Well, I'm going through and saying if it's a function or not first.
It's not a function.
Not a
because
function.
It would fail that
fail.
vertical line test.
It would fail. Definitely a function. All
Okay.
right, now one-to-one. So we're only looking at the ones that are functions, and we're going to put a horizontal line in. So that first one definitely
Nope.
not going to work because it would hit it twice.
1, 2.
Number 2 we don't have to worry about because it's not even a function. If
It
it's not a
would.
function, we don't
Exactly.
even evaluate it. Okay?
Not a function again.
What about the linear line?
Yes, it is. Because again,
It would
look at all those
pass
lines.
vertical and horizontal, so it is a function, and it's a one-to-one function.
Whoa.
Now, one more classification is whether a function is even or
Or
whether odd.
Now you have to be careful because even and odd functions are different than even degree or odd degree. So just be careful with that. Just throwing it out there.
Yep. So for a function to be even, if f of x equals f of negative x. So your opposites are the same thing. So if you plugged in positive 2 and then you plugged in negative 2, you get the same y value.
Same answer.
It will have reflection about the y-axis.
Good old reflections from geometry.
Now, odd function is that when you plug in opposites, you get opposite values.
Yes.
Okay? That's just the notation of it. And if you look at a graph, it will have reflection about the origin if it's an odd function.
This is the same as rotation of 180. Just
Yes.
throwing it out there for you guys that remember rotation of 180 from last year. Okay, and just notice in both, we're substituting into x the opposites. So like x and negative x, 2 and -2, 3 and -3, etc., etc.
Even opposites pop out the same thing. Even opposite pop out, whatever.
And then opposites. Odd is easy. They should say odd because it's odd, O. Odd, opposites, opposites.
Okay, so I'll look at, so we're trying to decipher if the absolute value of x minus 4 is an even, odd, or neither. Okay.
So if we look at the x column, if we were to graph that and get the table, I see -2 and 2. I could also do -1 and 1, but we just chose -2 and 2.
'Cause they're
and we got the same
opposites.
thing. Yeah.
So when that happens, we know that it's even.
Look at that.
Plus, if you were to reflect it about the y-axis, it would have reflection, so that is definitely an even function.
Even.
Okay, so the notation too is kind of important. F of negative x is the same thing as f of x. And again, we just looked at -2 and +2 to see that.
All right, let's investigate. So we have a calculator's table options. We're going to fill out this table. We're just plugging and chugging essentially. -3, -2, -1, boom, 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 boom. Okay. So right there again, I'm seeing my opposites. I could have picked -2 and 2, -1 and 1, and I see that they're the same number but with opposite signs. So opposites is
Odd.
boom.
Okay, if you were to graph this thing, it would look like, oh, look at that sketch come up.
So remember, if you were to turn this to the left twice, it would still look the exact same. That's the rotation of 180.
So because it has
Reflection through the origin.
and opposites pop out opposites, it's an odd function.
Boom. Odd.
odd. Now, algebraically, this is how they'll ask it in the Regents exam. Determine algebraically whether each of the functions is even odd or neither. Algebraically means you're using x.
Yes. Okay. Some of you are going to go with this, opposite numbers. So you can put a 2 and a negative 2, a 3 and a negative 3. When they say algebraically, you have to put in x and negative x.
All right, so f of x is already done. They've told you f of x is x divided by x squared minus 1. Leave it like that. Now, let's plug in f of negative x. So when we do that, we fill it in. And then I notice on the bottom that if you square any negative, it's still going to come out positive. So that's why I rewrote it on the right to look like that. And if you think about it.
So now we have this fraction, which looks the same as this fraction, but there's a negative. So they're the opposite of one another because they have opposite signs.
So it is a odd function.
Look at that.
If you look at the graph quickly, because again, if you have no idea how to do it algebraically, you can still get a point or two by just telling us, oh, this is odd because it has reflection about the origin. Mm-hmm. You can go that route.
See, there it is.
Oh, I reflected it. Nice. I forgot I did that. See, look at
that rotation. That's pretty. So see how it looks the exact same thing? This guy's still there. Boom, boom, boom. It still looks the same.
Okay.
That's it, everybody. Have a great day. We'll see you in class.